We got through Unit 1 and Unit 2 retests. Remember, from here on out, all of the retests will be done at the very end of the quarter. So for absolute value, this is at the end of the quarter. So it will be soon after that absolute value test. But I graded lots and lots and lots of retests this week, like probably almost 30. And I guarantee you I had less than 10 people improve their grade. Okay? So shout out if you did. Congratulations. Thank you for not making me feel like I wasted all of my tutorials this week. But that being said, you got to remember, if you are retesting something from the beginning or middle of a unit at the very end, you are still responsible for retaining that information. We have to be able to retain information from unit to unit. Math always kind of builds, and there are going to be some skills that will carry all year long in here. However, Algebra 2 is kind of chunky. We study one function at a time, and so they don't always flow very easily, but when you go, y'all know that y'all's next class is starting next year, you guys can enroll in AP, not advanced, AP pre-calculus. So next year they're offering on-level pre-cal and AP pre-cal. So we have to prepare y'all to be ready for an AP class. And those teachers are going to expect you to walk in and know a whole bunch of stuff from Algebra 2. Okay? There's a lot of overlap from the beginning of pre-cal and then the kind of later, more second semester of Algebra 2, but a lot of foundational skills that you need to know from this semester. So we've got to be able to retain that information. And if you're learning it the first time, then it should be up there. You just have to pull it out. But okay, anyways, that's my little spiel on that. So we're having day 2 of solving absolute value equations. No check for understanding today. We will do a check for understanding. It's kind of a big one. Next class, it's 4 problems, so it's not crazy, but it is 4 problems. And it will kind of have all these various levels of absolute value problems that we're kind of baby stepping through. Inequalities is what we'll do next week. Similar, not crazy different, but a little bit different. And then we have review day. And then again, on the 2nd is y'all's final test. And it's worth 3 grades. So don't blow off transformations. It's going to be 2 weeks from when we did transformations to when you do your test. I'm expecting you to retain information from 2 weeks. Okay? Even if we take a little break on transformations for the next couple days. All right, so that's what we got. Let's get ready. Remember, we're on page 9. We're going to do problem 9. Real quick as we go here, I'm just going to write a couple of steps as a review. Steps to solve. Okay. The first thing that we always have to do is we want to make sure that our absolute value, AV, is isolated, okay? We need our absolute value bars. Doesn't really matter what's inside of there, but we got to get those absolute value bars all by themselves. Prefer them on the left, okay? So you had to do that on a lot of your Delta math. That was kind of when I would do I would let B equal something for a minute, isolate it, and then I would go back there. We'll see some of that starting on the second problem. The other thing that we wanted to make sure last time is we wanted to make sure once we got our absolute value isolated that it was equal to a positive number. Okay, because what do we know? Can absolute value equal a negative number? No. And that's important. So if we got a negative number on the other side after we isolated, and that's the key, it has to be after. I had several of y'all in this class try to say your Delta math was no solution because there was a negative on the setup. But when you actually isolated it, it ended up becoming positive, so there was a solution. Watch out for that. Save yourself the work, okay? Make sure it's equal to a positive number. Today, when you look at we get our absolute value isolated, it's not going to be equal to just a plain number like it was all last class, okay? So I'm going to flip real quick. These were all equal to a constant. Constant means there's no variables over there. If there was a negative constant, no solution. This one was equal to a positive constant. Every problem we did, when we got it by itself, it was equal to a plain number. That's called a constant. Today, they're going to be equal to expressions. So we're not going to be able to look at the problem and know just from looking if it's a no solution. We actually have to solve it out. So that's kind of option, or the first thing that's a little bit different. The second thing is we're going to start seeing solutions or problems here that like one guy works and one guy doesn't. Because remember, graphically speaking, you do have a possibility for your absolute value graph to intersect with a line only at one point, okay? And so we drew some of those. So we're still doing like the possibility of getting 2. Today we're going to introduce the possibility of just getting 1. But we also might see some where we have none, okay? So it's been a build-up. Now we got to jump into it, take these problems up a level. So after we get the absolute value isolated, make sure it's not equal to a negative. Then we split. Oh, I can't spell. Split into 2 equations and solve. And then step 4, y'all's favorite step, is to check solutions. And I know you don't like it, and I know it takes time, but you're going to have to get over it because it's important, and we're really going to see today why it's important and when we have stuff that just doesn't work, okay? So that's just a quick recap. We did a lot of these last class. We got a couple more. There are a ton of problems in here. I was looking at this and I was like, oh, we're not doing all these. So I picked a few to do with you. I'm going to have you try a couple. We might even skip some. I'll try to get them all worked out and on Canvas in case you are going back, but there's just a lot. And a lot of them are kind of repeats. So I don't think you're going to be upset if I skip some, are you? I didn't think so. Okay, so I'll try to work them all out. But here we go. Let's jump in on number 9. Okay, is our absolute value bars all by themselves?
Yes.
Yes, on the left-hand side. We don't know if this is going to be possible or not possible because there's an X over here. So I just have to work the problem and really, really be careful with my checking. So I am ready to go ahead and split this into 2 separate equations, dropping the absolute value bar. Now you got to be kind of careful when there's more than one thing that's not in the absolute value bars. I'm going to have 5x plus 7 equals 3x minus 4, just the exact same equation minus the bars, okay? But on the other side, I'm going to have 5x plus 7, and I have to negate that entire expression. So I'm going to write it out as like negative and then parentheses around the 3x minus 4. I'm going to write it that way at first. If you can distribute in your head, more power to you. But you have to make sure you negate the whole other side. That means the signs of everything flips. Are we okay with that? It's a little bit different than just a number. Okay? Yeah.
So are you multiplying it by a negative, or are you just like flipping the signs?
It'll the same thing. Those are the same things.
But like, oh, never mind.
So I'm going to end up solving 5x plus 7 is equal to negative 3x plus 4. Okay, so if you can recognize I got to flip, you can go straight there. I always write it as like distributing in a negative, but I sometimes show more work, especially when I'm trying to teach. Okay, all right, so let's do the positive one over here. 5x plus 7 equals 3x minus 4. I need to move my x to one side. Which one do y'all want to move, the 5 or the 3? The 3 would definitely be easier. So subtract it over, and that's going to give me 2x, and then can we move at the same time?
Yeah.
So if I subtract over the 7, negative 4 minus 7 is? Okay. And then I divide by 2, and I get x is equal to negative 11 over 2. I said a lot of times last time, fractions are our friends. Fractions are totally possible answers. Negatives are not problems as solutions. Negatives are a problem when you have absolute value equal to a negative. So I'm not just going to throw that out because it's negative. I'm going to hang on to it. I'm going to check it in a minute. Now, over here, again, I have to distribute that negative into both sides over there. And then now I'm going to solve this way. I'm going to kind of go the same way. I'm going to add over the 3x to the 5x, and that's going to give me 8x. I'm going to subtract over 7 from a positive 4, and that's going to give me... And then this answer is going to be negative 3 over 8. Again, both are negative. Okay? Now, how do I know I actually get to keep them? Got to go back in and check. Okay? So important that you check with these types of problems that you have linear factors over there, okay? Again, the problem is getting absolute value equal to a negative. So here we go, back to the original problem in ink. I'm actually gonna check right here. I think I have room. 5 times negative 11 over 2 plus 7, all of that inside the absolute value. On the other side, I have 3 times negative 11 over 2 minus 4. Okay, to help you with your fractions. There's really not a lot of help with fractions in here. All right, this is going to be absolute value of negative 55 over 2 plus 7. Yeah? Okay. 3 times negative 11 over 2. Negative 33 over 2 minus 4. Okay? Can I know what's going to happen?
Yeah.
What's going to happen?
You have a negative.
I'm going to have the absolute value of something equal to what kind of number?
Negative.
Is that allowed?
No.
So what am I going to do with that?
Stop it.
Throw it out. Okay? So I'm okay if you get something like this and you're like, ugh, I don't know all that, but you recognize that that right-hand side is going to be negative. I'm okay if you just kind of write, oh, this is going to give me absolute value equals negative, throw it out. This is how I want to see on your test. Listen to what I'm saying. When you get extraneous solutions, this is extraneous. Extraneous. I just write extra because I don't really know how to spell very well. Okay? I have to see that you algebraically solved for it, but then I also want to see that you recognize it doesn't work. So just put a big X over it. Don't circle it. If you circle it, I'm assuming that you're keeping it. But here's another thing that people do. It drives me crazy. They'll get the next extraneous solution, and they literally like color it so dark, and like I can't see the I want to see the number. I want to see that you found it. I want to see that you knew what to do with it, and then I want to see that you labeled it extraneous. So we all understand what I want, because you're gonna have these on there. Okay. On the other side, let's do the same type of thing. So I'm gonna have absolute value of 5 times negative 3 over 8 plus 7 equals 3 times negative 3 over 8 minus 4. Okay? Let's just practice with our fractions here. What's 5 times negative 3 over 8? Negative 15 over 8 plus 7. Okay, that's some number inside absolute value bars. What about 3 times negative 3 over 8? Negative 9 over 8 minus 4. But what kind of number is that going to give me? It's going to give me a negative number. So is this a viable solution? No, this is also extraneous. So is there a solution to this problem? No, there's no solutions here. But I'm going to want to see in a problem like this, you can't tell from the beginning that it's a no solution. So I need to, like I said, see your algebra, see you recognizing it doesn't check, and then go from there. Let me see if this shows up graphically so you can kind of, how do I just had a brain fart. How do I get absolute value again? Okay, I'm going to have to think. Our next brain break. I'm going to try to pull one of these up and graphically show you. What? I got the wrong equation?
No, I was looking at like the wrong equation to plug it back into.
Oh, okay. Yeah, you always got to go back into an absolute value equation. Why am I having brain issues? Does anybody know remember how to get absolute value in the calculator? I was going to teach all that before the SAT. I'm going to have to Google because I am drawing a blank. It's questionable what's going on with my brain. Okay, here we go. Let's just jump to number 10, and then I'm going to have you guys try some, and then I'll figure out. I want to show y'all, you don't get a calculator on this unit. But since you take the PSAT in a couple of weeks, and there is a calculator embedded in there, it's all online. I went to a training yesterday. It's going to be kind of cool. I do want to show you how to do that because it is a good skill. I just can't remember how to do it myself. All right, here we go. So, step number 1, is our absolute value isolated? No. So I'm going to do that little substitution thing that I did. I'm going to let B equal, what is B going to equal in this problem? Absolute value of x plus 6. Okay? I'm really hoping that doing this, I know it's a little bit of extra work. Not really. You still have to do the same thing. But I'm really hoping that this might avoid having some of those problems where people do illegal math. So this is 3b plus 6 equals 9x. Okay? We're solving for b. Don't worry about the fact that there's an x over there. Just leave it. Okay? So the first thing I need to do to get b all by itself is move what? How? Minus 6 on both sides. So this will give me 3b equals 9x minus 6. Why do I have to write it like that? Can I subtract a 6 from a 9x? No, not like terms. Okay? And then what do I do with the 3? Divide everything by 3. I'm going to do it all individually because I do want to keep these terms separated like that. And thankfully, 9 and 6 are both divisible by 3, or else this problem would be less fun. So this is 3x minus 2. Okay? So it's kind of a similar problem. I'm going to go back to the absolute value now. And I have absolute value of x plus 6 is equal to 3x minus 2. Because I've got this linear factor over here, I don't really know, can't tell from the beginning if it's going to be a no solution or one solution or two solution. I have to go find it out, and I have to go check my work. Okay? We okay up to here? All right, split it up. X plus 6 equals 3x minus 2. X plus 6 equals negative, whole thing, 3x minus 2. Yes.
If we can kind of just do that negative 3x minus 2 in our heads, are we able to just write it as x plus 6 equals negative 3x plus 2 immediately?
Yeah, I'm okay with that. Just make sure you change them both. That's the big thing, is sometimes people just change the first one. So that's why I always write it two ways. Can you see?
Yeah.
Okay, so algebraically, we should always algebraically be getting two solutions because we have to split it into two equations. Now the question is, do we get to keep both of the solutions? And that's where we have to go back and check, okay? Technically, listen to what I'm about to say here. I'm always going to check in the original problem in ink. That's what I'm always going to check in. Technically, you are allowed to check in the isolated absolute value equation, and yes, it is easier to do. However, I always go to the original because in case you made a mistake in your isolating or anything else, I just always like to check in the original. But you have to check in an absolute value equation. That is like the big idea. It has to have absolute value bars, okay? So you decide how you want to do it, but I'm going to check in here. So I have 3 times the absolute value of 4 plus 6 is equal to 9 times 4. When I'm checking in this, I'm going to work my absolute value. Like first, 4 plus 6 is 10. The absolute value of 10, take that absolute value. What is the absolute value of 10? 10. So 3 times 10, I can now drop the bars because I actually did that operation. Is that equal to 36? 3 times 10 plus 6, does that equal 36? Yeah. I'm okay if like this is the amount of work you show on that. Like I can see what you're doing in your head here. So is 4 a viable solution? Yes. 4 is going to work. Okay. Let's look at the other side. So I have 3 times absolute value of negative 1 plus 6. Close absolute value plus 6 equals 9 times negative 1. Okay. This absolute value is not all by itself on the left-hand side, so I kind of got to work this problem. Negative 1 plus 6 is 5. The absolute value of 5 is 5. So 3 times 5 plus 6. Is that going to equal negative 9? What is 3 times 5? 15 plus 6 is not negative 9. Okay? So is this solution going to work? No. Okay? So here's an example. We haven't seen one yet that you solve for 2 solutions. One of them works, one of them doesn't. I told y'all we weren't going to see it last class. Well, here you go. You are going to see this sometimes. Okay? All right, I want you to try, let me see what I want y'all to try real quick. I want you to flip over and try 11 and 12. We're going to skip 13. 11 and 12, y'all try on your own. Number 11, I got 2 solutions, and they both worked. Okay? With your checking on the x equals 9, that should have been pretty easy to check. With the checking with the negative 5 over 2, if you change that to negative 2.5 to deal with the numbers, that's okay. I don't like decimals. I stuck with fractions. Just a quick recap. We've talked about multiplying fractions a lot, so you should be able to get here. How I got to keep going was I did the subtraction and addition between the fractions. I just got a common denominator. So I wrote 4 as 8 over 2. I wrote 14 as 28 over 2. Nothing like groundbreaking here. When you add and subtract fractions, though, you don't change the denominator. It's just the numerator that changes. You just do the operation on the numerator, and then you leave the denominator. And so this one did end up working. But again, if you go to negative 2.5 to help you, that's all good. Okay? Number 12. Again, I got 2 solutions algebraically. However, neither of them worked. They were both extraneous. So the answer to this, the answer to this is no solution. Okay? But again, on a problem like this, you can't tell from the very beginning. So you actually have to show, okay, I got these, and then I saw that they didn't work before you get no solution. That's how you could get full credit. Okay? Before we move to number 14, I just want to go, is everyone okay with this? Can y'all see? Okay. I just want to show you like an example graphically what is happening with 9 and 10. So remember on number 9, well actually I'm going to do number 10 because I have that typed in right now. On number 10 right here, okay, you don't get a calculator on this unit. Let me just preface with that. I just want to show you how to use this calculator. If you're somewhere that you can, like the PSAT, they have this graphing calculator like embedded in the software. So what I would do if I were to solve this graphically or look at this graphically is just type the left-hand side in Y1, the right-hand side in Y2. So I can type this left-hand side exactly as it is, 3. And then to get absolute value bars, I remembered, I knew it was in my brain. I'm going to press this math button right here, math, press math. There's a lot of stuff in math, but if I go over to where it says number, the first option says absolute value. So math, number, and then press enter. And that gives me absolute value bars, and I can type within there. Okay, plus 6. And then in Y2, I'm going to put 9x. Now, I'm going to graph it. I don't know if we're going to see it in this window because I was really zoomed out. Yeah, we're not going to see it in this window. So I zoomed out on my graph, and then I was able to see, remember on this problem, it only one solution worked and one didn't. So when I zoom out, you'll see right here, I know it's probably kind of hard to see at the very back, but I had my absolute value graph. I did have one intersection point right here, but that's the only time that it's going to cross the absolute value. So that's why algebraically one worked and one didn't. Okay, same thing with that other graph, just so you can see both. If I have math, num, abs, 5x plus 7, and that's a 1, 7, and then 3x minus 4. And if you don't care about this, then that's fine, but I do think that it is important for you guys to know how to work the technology, just because we don't always use it, and it is important. And so you can see here that these guys are never going to cross, because you've got your absolute value, it's kind of skinny, and then you got your line underneath it, and it will never cross. That's why both those solutions were thrown out, okay? So food for thought, math, number, and that's just to scroll right, and then absolute value if you need it. Okay? All right. I worked out 13. If anybody worked out 13, I got 2 solutions that both worked. If you didn't, that's okay because I said you could skip it. And then let's go to 14. 14 has absolute value equal to absolute value. Good news. This is not really that different. Okay? This is not really that different on how we're going to solve this problem. We're still going to split it into 2. Okay, first take note. The stuff inside the absolute value bars on these are like totally different, right? That's the first thing. Okay, and then there's nothing outside of the absolute value bars. So in a problem like this, where your absolute value bars did have something different in them, you're not going to have stuff outside. You'll see what I mean in a little bit. So as far as solving this, you still split. Shh, quit talking. You still split and drop the bars. And it's almost as if I'm going to treat this right-hand side as if those absolute value bars weren't there. They are there, and that will matter when I check, but I'm just going to like set the equation as is, like no sign change. And then on the other side, I'm going to drop the absolute value bars, but I do have to change the signs. I'm going to keep doing it on the right because that's what we've been doing. So even though it looks different, it solves the same way. Okay, and you're just looking at an absolute value intersecting with an absolute value graph. Okay, so they solve the same way. No need to stress. It's not anything crazy. Get your solutions, check them, ready, go. Here is, I've got 14 up here. They do check out. 15 has a fraction on the X, and the front of the room voted to do 16 instead of 15. So that's fine. And then work on that. We'll compare. And then we've got our final type of problems, which are really super fun.
Do we need to know how to do
Work out number 15, if for anyone that's interested, but we opted to do 16. That's fine. When you are solving these guys, just to actually get your possible answers, you drop the absolute value bars, you do the split, you do the opposite thing, we're all good there. When it comes to checking, when you're checking your work, you are not solving. There are no variables when you check. You are evaluating. You're finding a value, and you're making sure that they're equal to each other on both sides. So when I get to like here, absolute value 4 equals absolute value of -4, I can perform the operation of taking the absolute value of 4. What is the absolute value of 4? 4. That's an evaluation. You just told me this is what this is. The absolute value of -4, I can take that operation and I get the number 4. So I don't want you to think that checking as another solving, because it's not. And I need y'all to know the difference. When you evaluate, there's no variables. You're just working your numbers. You're doing your mental math. You're trying to find a value. Evaluate. When you have X's in there, that's when you're solving. You've got to know the difference between the two, okay? All right. Are we ready for the scary problems?
I know, I've seen it.
We are ready. We can do this.
It's so
We are confident.
Then they have the same thing.
Whoa!
We are confident algebra all-stars here. Let's go. Let's go. Hey, if your computer is open, close it now. I'm about to lose my patience.
Which one are we doing?
Okay,
17?
17. No. You're going to want to do some of these. Yes. That is not the goal. No. Listen. Simmer down, everybody. I know it's Friday. I know we're getting ready to go beat Lone Star, okay? Yes.
We're gonna lose.
Not with that attitude, people, okay?
We just know they
No, we're not. Shh. Okay, hey, focus. This is on the video. Everybody that's absent is going to be like, what the heck is going on? All right. We're going to put a big star by this question. Okay? Big star by the question. Probably a big star by all three of them because there's two here and there's one more on the back. But you are going to see problems like this again in your practice. You're going to see problems like this on your review. You're going to be seeing them on the test, okay? You might even see it on the PSAT. I don't know. They're not that bad. So lock in. Here we go. Okay, first of all, there are more than one set of absolute value. But what do you notice about our different sets of absolute value in each problem? What's inside? The same, okay? So that's what I said. If I give you absolute value equals absolute value, they're probably not going to be the same inside. But if I give you multiple absolute values and there's extra stuff, there's a 4, there's a +7, there's a 16. But what do you notice about those absolute value bars? They match, okay? So we're going to do what we did last time. We're going to let B equal the absolute value of 1 minus x. We chose the letter B last class. This class chose B, so I've just stuck with it the whole time. Okay?
E plus
Let. L-E-T.
I thought that was like the absolute value. I thought that was.
Let B equals. This is not math.
I thought that was the start.
I just have really sloppy handwriting. It's okay. All right, so here we go.
Absolute value of E.
Let's rewrite it. Let's rewrite it, plugging B in. 4B plus 7 equals 16 plus B. Now, what do we have to get all by itself? B. All right, but this time we have two B's on opposite sides of the equal sign. It's like an X. It's like Algebra 1, variables on both sides. It's just like these problems that you solved over here. What should we do? Which one should we move? 4B or 1B?
1B.
Okay, I'll show the work. I'm going to subtract it. And that's going to give me 3B plus 7 equals 16. Then I'm going to move the 7. Okay, what is 16 minus 7? 9.
I don't understand these.
What is, hey, divide both sides by 3, and what is B equal to? 3. Okay, let's plug B back in. B is the absolute value of 1 minus x. And now I have it equal to 3. And this is a level 1 problem that you did last class. Okay?
Oh.
Is this possible? Is it possible to have absolute value equal to a positive number? Yes. Okay, so this is the same, other than how crazy it looked at the beginning. We isolated our absolute value bars. We got the absolute value by itself. And all you got to do now is do your split. It's what? 1 minus x equals 3. 1 minus x equals negative 3.
Did you plug back into the top one?
I'll let you plug it back into this one, as long as you promise to remember that you have to plug it into an absolute value equation. I'm going to put an arrow right there that says I could check in here. Okay? So it only looks scary. It doesn't solve. It's one of the easier ones to solve today. With checking, hear me out. Hear me out. You have to check your solutions on every single problem we've done today. You have to check in an absolute value equation. I've been harping, go back to the original, because it has been such a long day of solving. Technically, it is okay to check right here. But why is this equation, why am I allowed to do that? Is this still an absolute value equation? Yes. So once you get that absolute value isolated, again, it is okay to check in that one. Just be very, very careful. You should never be checking in after the split. It always has to be before. You always have to have absolute value bars where you're checking. Just fair warning, people mess that up, so be very careful with that. So I can check this right here. You can try 18. I'm going to finish checking this one.
Once you figure it out, it's not that bad. Maybe he can pay you to be his tutor. For me to be his.
Okay, hey, when you finish, real quick, there's Delta Math.
I finished.
Okay, you can go. There's 18, there is a 19. I'm going to do it. I'm going to do 19. It's kind of scary looking, but I'm going to do 19. It might be good to practice at some point in your life. But you should be able to get the Delta Math done on day 2.
Do it. Can you give me tips? I have your paycheck.
So, look. Shh, hush. 3.2 day 2. You got 3, 4, 5 problems again.
Oh, that's a lot.
Okay? 5 problems.
It's not that much, actually.
And over 48 hours because you get a
Oh.
weekend. Yeah, no, that's not a lot.
Yeah, well, no, it's
Yes.
36